Okay, so hi everyone. Today we're going to solve another problem, and yeah, and the problem is 127 LeetCode word ladder, and it is a hard problem. Although if I have to personally give my opinion, then I will say that this is not a hard problem. This is more like a medium problem, and in mediums, I will say that it's a good problem in a medium level. It's not an easy medium. It's a medium and hard level, but not definitely not the hard ones. Definitely not among the hard ones. So the problem is a transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words begin word to S1 to S2, and so this is a string basically, such that every adjacent pair of word differs by a single letter. This is quite complicated explanation, but I will give you what they do mean by this. So every SI in from 1 to ik in is in word list. Note that begin word does not need to be in word list, which means that so you were given a list, you were given a string, let's say begin word, and this is in this case is hit, right? You need to go to s1, a string 1, then to s2 and up till sk. And sk is nothing but your end word, and which is cog. So sk should be cog, and the word list is hot, dot, dog, lot, log, and cog, right? So this is a thing. And so let's say from hit, the nearest one that you can produce is hot, right? And there's nothing else that you can produce. You can also from hit you can, yeah, so this is the nearest one that you can perform get, right? And why? And this is the condition. So every adjacent pair of words differ by a single letter, which means from hit only one is the difference, and that is I and O. From hot I will say that let's take um let's differ this h and have dot, right? And we have dot, and there's only one difference, fine, this is fine. And from dot I will differ t letter and I will say dog, dog. And from dog I will differ only one letter, and that is cog. And cog is my end word. And how many sequences do I have to make in order to get this word? 1 2 3 4 5. So we get it at fifth iteration, which means fifth is our answer. So we need to return the shortest transformation sequence. So by shortest, I can clearly see, first of all, my thought process went in this way that this could be a dynamic programming problem. But then I realized that um, we are not much relying on the previous part. We are more relying on the current part and checking it in the list. And because it's the shortest given, so this makes me think that this could be solved with BFS, right? This was my basic intuition that BFS could be used. And then I have to brainstorm how to use BFS. So I had a brute force technique with me, which I did not use the solution section to have this technique. And I thought that brute force technique is very expensive. So my technique was, for every element in the queue, for every string in the queue that I will take out of this queue data structure, I will, for every character of the string, I will try to change its character, to A to Z letters. And if that changed string is present in the word list, if it is present in the word list, then it means it can be stored in the queue and processed further, right? This was my basic approach. And I was so unsure that this won't work because it's very unoptimized and so on, and it's a hard problem, so definitely it wouldn't work. But then I see the constraints, and constraints are very low. So the constraint is 10, which means that for every character, if I do 26 operations, the A to Z letter, then it's 260, which is nothing, which is a constant operation. So I can definitely do this. And the word length that I have is 5000, which means I can definitely have an n square algorithm for this case. So my BFS approach was, so I have hit basically, right? So let's see that we have put hit. So we have a node, right, that we are storing in the queue, and hit, and we have one, that is the discovery time of hit. So this is my sample space where I will create the test cases. So let's change this character. After changing this character, we have AIT, we have BIT, right? We have multiple these strings, but you can see that in word list none of them will satisfy the condition because we don't have I in between of any strings, which means that changing this character will not work, although we have to try each and every possibility and check if that string is, if the change string, if ait or bit is available in the word list, but it doesn't, right? So I will create a word list as well just for your reference. So this is hot, this is dot, this is dog, this is lot, this is log, and this is cog, right? This is the word list, and I can clearly observe that anything that is starting or ending with it is not there in the list. So let's move further and now try changing I. So if I change I, we have hat, we have hab, not sorry, hbt, and further on there will be a part where I stumble upon and get this as hot, right? Because after some part I will see hot, and hot is available, right? Hot is here. So I will say that from hit I will have hot, and the discovery time will be 2. Okay, very fine. So from hot we have got the list. And is there any other that I can have with h and the middle element different, but the last and the first element is h and t? No, we cannot. So we will move further on, and here I will say t should be processed. So I will say HIA, HIB. Obviously we don't want to store HIV. Sorry guys. Yeah, and we have HIZ, right? So we don't want these strings because these are not available with us. So now we only have HOT as stored into the queue, HOT with 2, right? So now let's process. So now we are done with HIT. Now we will go to this part and we will get this out, and now we are processing it. So while processing it, HOT, I will change the first character. This is AOT, this is BOT, and you can clearly see that we will stumble upon something called DOT, dot, and dot is present here. So I will store dot here, and the discovery time will be 3. Similarly, we will also find LOT. Discovery time will be 3 again. Discovery time will be 3, right? So after this part, I will try to change O, but you can see that every element should require O in between, so we won't find anything. And then I will try to change T, but there is nothing that is starting with HO and ending with T. So I can clearly observe that it will not store any other element in the queue. Now we have DOT with 3 and we have LOT with 3, right? After having these elements, now we can process DOT. Let's see. So if I change this first letter, right, it will, so, and yeah, one thing more, I am also removing these letters into my set. So HOT is removed because we have got that. DOT is also removed because we have got that. LOT is also removed, right? Now we have DOG, LOG and COG. So from D, if I change anything, it won't give me anything because we don't have OT ending with anything. So I won't change it. I won't change O, but I can change T. With changing T, I will find something called DOG. So the sequence will be DOA, DOB and DOCGH, and then I will have DOG, which I want. So DOG, I think we are looking for COG. Okay, so from this part, now I'm processing this. I will get it out of the queue, and my queue is like this. Now I have LOT as the remaining node, and I will store DOG, and the discovery time of DOG will be 4. Fine. And from DOT, can I have any other character? No, we cannot, right? So I will also try to and now I have DOG, so I can remove this from the set, and now I will process LOT. So while processing LOT, you can see that you can have LOG with the discovery time of 4, and you can also, yes, that is it, and you will also store. So you have dog with discovery time 4 and you have log with discovery time 4. Now from dog, this is interesting. The first changing the first character will make it aog, bog, or cog. Cog is the required answer. You will say that I have got cog, and cog, the discovery time will obviously be 1 plus the discovery time of the parent node, which means that cog will have 5 discovery time, and that is the answer, right? So this is it. Let's solve this. Let's solve it. So we have, first of all, yeah, we need an unordered set of string in order to keep a track of the string is present or not. We need to check for every string that we are creating from these nodes that if the string is present or not, and then push it into the queue. I will say it as, and I will begin this with word list dot begin, word list dot end. Now you will also have another thing that is queue, and it will have a pair of string and int for time, and this is queue. I will initialize this value with the begin word, and the time will be 1, right? But before that there is a condition. So if the end word, we need to find the end word in the set, because if it is not there, then we can never have our answer, right? In that case, we simply need to return 0 because we won't find the end word in the list. So this is s dot end. So if it is not there, then simply return 0. Otherwise, apply BFS, and BFS is q dot empty is false. Now you will get string, and that is str is equal to q dot front dot first element, and you will have int time that is equal to q dot front second element, and with this you can apply your for loop. And we also need a character, let it be temp, and I will show you why do we need this character. So you will iterate over each and every element of the each and every what do we say, letter of the string. So I is less than str dot size, fine, I plus plus, and yes, now we are going to change the letter. So c is equal to initialize with a, c is less than equal to z lowercase z, and c is incrementing, which means that c is now becoming a, b, c, z, and up till z. So I'm using temp variable in order to store the previous character of the string, because I don't want the string to be changed, right? So temp is equal to s of I or str of I, and then I will change the string, that letter, and that will be equal to c. Now if c is, so first of all, if str, after changing this letter, if str is equal to, so there are two cases. So if str is equal to the end word, in that case I have got my answer and I can return time plus 1. Otherwise, if str is not equal to the end word, then I need to check if str exists in the set. So I will say set dot find str. If it is not equal to s dot end, which means it exists in the set, and in that case, so first thing is I will remove it from the set, erase str, and after that I will push it into the queue, and that will be str and the time plus 1, because time is increment, discovery time will be 1 plus of the previous node, right? So yes, and now we will change back the character. So str of I is equal to temp, and after this process we will have our answer. And if we are not able to have our answer with the BFS approach, which means the element is not present, or if it is present, then we cannot follow the same structure, like going that there should be one difference, right? There could be an element, for example, so there could be a case where there is no one difference. For example, you have, let's say, HOT and you want to get DOG. So this is the begin word, this is the end word, this is the end word, and the word list is HIT, or let's say HOT and DOG, right? So from HOT, you will try to, so from HOT, you only have one option, right? So you will say DOG, but that is not possible because you are changing two letters in this case. In one sequence transformation, there should only be one letter difference, but there is two letter difference, which means that it will return 0, that we cannot possibly achieve that end word string from the begin word. So I think it makes sense. Let's run it. There could be some errors and we will fix them if there are. Yeah, the error is that we are not popping the element. Yeah, this will fix it, I think. Okay, it's fine. Now let test start this test case. That is, so we have HOT, then we have DOG. Let's remove this. Right, so the answer of this is should be 0. And the answer is 0. Fine, it's working. So let's submit it. Okay, cool. It gets submitted. Not so idly fast, but not so bad. Okay, memory wise it's performing good. Isn't this the same approach? I don't know how this, I think in using an array is more memory wise or efficient than using a vector or a queue or any other data structure. But we are not using anything. I don't know, man. I have to research this topic and find how to space optimize things. Although if you are using it, if you are preparing for competitive coding exams or learning these concepts for competitions, then it will be fine. So yeah, so this was it. Thanks for watching, guys. Have a good day.